Welcome to Chapter 8 from Corporate Computer Security. Going to be talking about application security, but trying to keep it understandable for someone who is not a programmer. In the textbook, if you take a look, I think they talk a lot of geeky programmer language terminology. I'm going to try to explain that as we go. And again, don't worry about memorizing the computer terminology, but get just a general idea of what you need to watch out for and why application security is a separate chapter. We talked about systems, networking, lots of topics. Now let's concentrate on the programs that are running on your computer beyond what the operating system is doing. That's what we think of when we think of applications. Your operating system has lots of programs running, listening to your mouse, controlling what's displaying on your screen, sending information over the network. The most common application you use is probably the web browser. But there's a lot of other things happening in the background, and just go to your task manager and you will see many background services. Each one of those background services is a program. It's like an application. If it's built into the operating system and automatically runs and it's helping the operating system do its thing, then we call it the operating system application or operating system service. But they are like little programs running, and they're in many ways like an application. So when we talk about applications specifically, we're usually referring to those extra programs on top of what the operating system is already doing. And there's plenty of complications in there. For example, the default settings in Windows 11 now is to start up Teams automatically, as though Microsoft wants you to have Teams as part of your operating system. I do not like that because I know Teams is a separate program I don't need to use until I am doing a team interaction. And they're just trying to compete with Zoom and beat Zoom at doing their thing, or Google Meet. But it's an application. But they've built it into the operating system, wanting you to think it's part of the operating system. So much so that the default setting is to have it start automatically. Fortunately, I can go to Startup Apps and disable those. And that's one important thing. I don't recall that mentioned in this chapter, is understanding startup apps and only running the ones that you know you need to be running. So the learning objectives for this chapter: basically understand applications and what do we need to secure them. We're going to talk about various categories of applications: web servers, the browser, the client side browser that visits the web services, email, generally both the client and the server side of that, voice over IP, and concluding with a variety of other applications. So, an application that is running, think of this, I thought of this analogy. Someone was on the internet playing a game, and someone else on the internet either felt cheated or didn't like this person for whatever reason. They found out that person's address, and they swatted them. They basically reported to the police in that town of the person that they did not like that there was a crime going on in that home. Here is the address. The person is dangerous and armed. Send police there. And the police, with the authority and the weapons needed for securing people, went to that home, and bad things happened. Because they were in charge, they had full administrative, life-changing privileges with the weapons that they carried, but they were fooled into using those privileges against an innocent person. That's kind of the same things going on in applications. If they have privileges of the system doing anything they want on a system, and they are fooled, compromised, they will do what they have with their privileges to steal information, or damage a system. So, in that case, do you take away the privileges of the SWAT team and say, no, you can't carry guns anymore because of what you did? No, then they don't have the strength to do their work. You ensure that they have the privileges that they need, but you are more careful about what they can do. Other people that want to be SWAT teams, you don't allow them, you make it illegal, and you take away their weapons if they want to act with the authority that they do not have the rights to because of training or how we want our society to run. Same thing on a computer. An application that should only be able to read your files and modify and edit your files should not have the ability to edit any file in the system. That is administrative level privileges or super user privileges. We do not want applications to have privileges beyond what they need to use. So that's the hardening of the security, is do not run commands, do not run command prompt as administrator, except when you absolutely need to. Once you have done running the command that you needed to run as administrator, close that command prompt and make sure when you install programs that you don't always run as administrator, turning off your antivirus, doing all the things that an administrator can do. You'll forget to turn the antivirus back on. Your application will have the authority to break your system. Buffer overflow attacks are something a system can do, an application can do to mess with your system. And just to give you the general idea of a buffer overflow, they get into the details and stacks and things. Think of it this way, that a program that's running, an application that's running, has instructions. And then it has places to store information that it's getting from you, such as the text in your editor. You don't want your instructions that the computer is following to somehow be changed into the instruction, go erase these files, or give me complete administrative access to the computer. That's called a buffer overflow. When I fool the computer when I'm trying to save data, I fool the computer into accidentally placing the data from a data buffer into code instructions. Now, some programming languages allow very complex and very powerful AI type things to happen by actually having control of the instructions that they're following. But that's a very dangerous thing, to actually change the instructions in the program. And that's basically what a buffer overflow can do. Fooling the program or the computer to save data that was supposed to be only there to read and multiply and divide and get results. And by overflowing it, fooling it to store data in the instruction location, overflowing the data location, you overwrite instructions. And one place that they can overwrite instructions is this thing called a stack. There's other places, but the stack is one place where it's storing where is the next place that I need to go to read an instruction. Well, if you can mess with that stack and give it the wrong location to go to another place, such as the instructions for giving me a shell, an execution shell, the command prompt, start that program up, I have fooled my computer into giving me command prompt capabilities, and if my program has administrative privileges, that command prompt will also have user or super user privileges. So that's the overflow attack. Getting data, basically fooling the computer to overwrite instructions. And remember, there are many applications, even though before running any applications and you do your process management, you'll see lots of applications running, lots of little processes running. There are many more applications that are running that each can have its own type of vulnerability. The server is the computer that runs programs for other computers to use, but you don't want to allow anything else running on that. You don't have web browsers running. You don't have movie players running on the server. You have the limited number of services. So here's a example of that stack entry buffer overflow. Basically, you have some code. You convince the stack to send you there. That's what this diagram is showing you. You somehow get the ability to overwrite something in the stack. Many ways to do that based on the different applications. Somehow you fool or you find a vulnerability in the program that allows this address to be written to in some way, and you know the address of your attack code. So the goal of the attacker is to overwrite, get the computer to say, oh, that's the next place I'll go to follow my instructions. Because remember, computers, all they're doing is following instructions stored in programs that are stored on disks, and if that file can be changed, you'll fool the computer into running the wrong instructions. So to harden it, you keep people out of your computer by locking it up. They can't open it up and replace things and reset things. Have backups. If it does get messed with or things break, you can go back to the clean state. Patch your operating system. Don't run applications that are not needed, and have some sort of limit, some control over baselines. Baselines are what your default installation configuration is. Go beyond that and change your default passwords of your applications. Always patch them, and the hard thing about that is each vendor provides patches in different ways. There are clearinghouses for checking for patches on systems, but this can be a full-time job if there are a lot of applications being used, constantly checking. Say you find an update needed for Office 2019. What do you do if you've got 1,000 users of that program with that installed on their computer? Well, the best way is to use Active Directory and require that installation of that patch after the next login, or immediately, or after the next reboot. But that's something you have to know how to do at the system admin level. You don't let applications run, even though if they run as administrator they don't get that error that's so annoying. You figure out what you need to fix in the program rather than run as administrator every time you need that program to run. You bother the vendor saying the fix is not acceptable to run as administrator. Send us the fix that will allow it, because we do not want to run that program with high permissions. It should only have low permissions. If it's supposed to be an editor, that each user should only have access to their own files. You've got various levels of auditing, and remember the problems with Windows auditing is horrible, but you have authentication from the application. For example, you run QuickBooks. You already logged into the computer, but yet QuickBooks has another level of authorization in order to be able to do more than check your own data. You have to have a password for system level authentication. So make sure that is working. The vendors have to have that additional level of authentication. If you want to keep things, passwords from being stolen, you encrypt the data along the way. Custom applications may be you might have some really smart programmers to write some nice applications to do the CAD on your machines out there in the workshop. And in order to be able to write to the files on those machines, you need administrative privilege. They may not realize that there's a flaw in that program that allows someone that either accidentally or maliciously fools it into doing everything they want on that computer, because that program was given full admin access because they want to program something out in the workshop. That's just one example. Again, they're probably not trained in secure coding. They're very smart in getting their particular application working, with cameras or measuring equipment. But writing code that doesn't allow buffer overflow may not be something they've seen. Something that we're going to see in the web-based applications as well is you may have users that accidentally type in the wrong thing. What will your program do if they type in the wrong thing? Typically it'll crash, and then you'll just say, oh, start it over if you type too many digits in that input. Well, think of the users as trying to break your program, and what could happen if they just typed in the right amount of input. Never trust input, always check, are they at the security level to get or change what they want, are saying they want to change. And filter what they're typing in case they are being malicious or drop the keyboard and some strange characters got entered. Interesting story just came to mind. We had a program that was written for our food services, for dining hall charging as they come in, and a student thought, hey, this is an easy program, I'm gonna write it. And they wrote a decent program that read the ID cards of the students. In that case, they could swipe them through a card swiper, and then they take that number and look up that student and see what they owed for the meal or would charge them for that meal. Well, I wasn't trying to crash the program, but I accidentally scanned my credit card instead of my school card, and it crashed the program. And I, of course, wasn't trying to. I just wasn't looking at what card I was swiping. Now, it didn't steal my credit card information. It actually crashed the program. They weren't protecting it from an accidental reading the different kind of data that you get off a credit card compared to a school ID card. Checking for these kind of things. There are programs written to watch for that, but it takes extra work to check for problems. Different languages are more powerful. Typically, the more powerful language may allow the more powerful attacks. For example, the C language basically allows you to write anywhere in the memory location of your system. Very powerful language using pointers and things, but you can do major damage if you overwrite the instructions, especially running as administrator. Some languages, they're just designed in a way that doesn't allow you to do anything like that because it's a harder concept, usually not in a simpler programming language. In a website, I know the login screen is typically login.php or login.py if it's a Python script. And if I know that the actual admin page is at the website /admin.php or admin.py, I can just type that into the URL and it takes me to that page instead of saying, oh, if you have a good password, I'll take you to this page. If I find out what that page is, I could enter the URL and just see, well, let me into that page, assuming I wouldn't get sent there except if I'd logged in. Well, that's a horrible way to program. You don't assume that they have permission. Any page you enter, you check, are they actually legit to come to this page? Seems obvious, but even good website programmers may not think of that until it happens a few times. Get into more detail on cross-site scripting, and in the book they walk you through some of the scenario there. Basically, think of it as I fool the website into running a script, or a malicious website installs script in my browser, fools my browser into letting me through to another system. So fooling your browser is essentially what cross-site scripting is doing. It's fooling your browser into taking you somewhere else. The information you were meant to give to the legit website goes to the other one. So basically messing with your browser. The lesson here is scripting, local client-side scripting languages have certain types of attacks they're vulnerable to. And here's the fairly vague sequence of steps where there's a script, and of course the browser doesn't show you scripts unless you put it in debug mode, which you can, and that's a very powerful way to check for websites. They go to the legit website, but they have a script that's been given to them, that's the browser is running, and will then get sent, the script then will run, and take advantage of some error, some vulnerability, either in the browser or in the web server. So think of the script as messing with the programming language that's running, that your browser runs in order to communicate in the background to the server that you're connecting to. You want to get more into the detail, feel free to read more, but that's fairly detailed programming level type information. Similar thing, what they call SQL injection. Just be familiar with that term. Basically, you're fooling the database server to do something it's not expecting when it's taking input. You can fool it by putting in bad characters that wouldn't be expected by a programmer expecting good users to only be using the system. You can actually, if it's not programmed correctly, fool the server into running queries. That's like a programming language for databases. Fool the programming MySQL program language into erasing data or showing data that you shouldn't see. And I think in the book they did a little example. They may have a little example here. Let's see if they show that. Yeah, here's an example of that scripting where they throw in this little character here. Looks pretty innocent, but if it's not properly filtered at the database side, this will cause the database programming language to do something completely unexpected and crash or give you information or change information that shouldn't be changed. So this little tick mark is a very important character in database programming language, and if you can fool it into thinking that that's a real thing and the programmer at the server side hasn't realized, no, I should watch out for that in the input, you can fool this database language into doing things that it wasn't supposed to do and let you through into the system. So basically you want programmers experienced and trained in secure programming techniques. Here's the path where we have the browser browsing to a website. It uses PHP programming language. I usually have it on the same machine. You could have a middleware server. And then it accesses the database through commands that it's expecting, through data it's expecting on an input, and that data comes in a bad way, fooling the system into doing the wrong thing. That's called SQL injection. Throw up that term to anyone using databases and say, hey, have you ever come across a SQL injection problem with your database? They'll think you're very knowledgeable about security in databases. Okay, securing web services. Remember, web page servers, they're providing web pages to you and to your customers coming in to buy product. And if I can disrupt that as an attack on your system, I can cause you to lose customers or deface your website or steal customers or fool them into paying me instead of you. So web servers are super important to keep secure. Now, e-commerce is like, think of that as you're charging your bank and the money's going to come from your bank. You can imagine the kind of attacks those are facing. If I can fool your bank into giving me money and you haven't, you've just come to my website once and I've somehow detected your password or your account number, that gives me lots of capabilities. If I can get money from you. So e-commerce services are a big target for hackers. There's different server programs. IIS is the Microsoft version. There's Apache, and there's NGINX. Nginx is also a web server, can run on Windows or Unix, typically Unix. They provide, the e-commerce servers basically allow people to buy and sell, and of course, if they're storing credit card information, that is very valuable if someone can steal that. So I've got custom programs, e-commerce software that interacts with web pages, and I might have other e-commerce software. Web server provides you the web page. E-commerce server provides you the connection to your bank to go get money. Think of PayPal. You can go to PayPal, it'll convince you to send your money to this place after you go over there and verify that you're buying that product. just a little example of the interface to the web server side of things. You won't see this unless you're actually wanting to be a web server running on Windows, but it's fairly user-friendly. Things that they can do to your website. If they can get in there as admin and actually change your website files, they can actually deface your website. If they know that your logo is displayed as image logo.png, and somehow they find out how to mess with your files, and they replace logo.png with a different logo.png that has your image or something that was embarrassing to the company, you've defaced their website. There's IIS is a program that probably still has vulnerabilities remaining. It's been around for about 30 years. But if I can fool that program into letting an instruction be replaced with the data I send it, I can send it instructions to delete or give me complete access to the computer. And this gets back to the level of that we allow that program to run. Where was that? If we allow IIS to be running as administrator all the time, because it's a very important service, if I fool it into doing the wrong thing, guess what? It's running just like that SWAT team. It can erase anything on that computer. So, one of the major things you do is you don't give IIS admin privileges. You only have it certain folders it can write to. Sure, you might be able to deface their website because it should be able to update the logo, but you can't get anywhere else on the computer if somehow the IIS server gets damaged. And you even limit the ability to rewrite files except for a specific folder. That's the only place where it can save files, and anything to do with what's displayed on the website can't be written except through special other paths that the attackers don't have access to. And that's what this is about. Fooling your IIS server or your web server or Apache or Nginx to have write privilege anywhere except to where it actually needs to be. So you don't let it go doing directory traversal. Even if it can't write to the files, it's useful to someone to know what files are over there, and with another attack know where to go to steal files. So you don't allow your web server to have access to any other folders on the server except where it's serving the website. So directory traversal can allow me all the way to get to a very powerful file on the system in Linux, a password file. So we patch that software. It's very important to patch that software and use the software that's most stable. Those three are very stable: IIS, Nginx, and Apache. There's other servers. There's even custom-built servers. Everything that has to be patched. I've heard that the military has their own version of everything. Seems like, not sure if that's the best use of the funding, but just because there's known vulnerabilities in the standard, the military has a whole different network protocol they use, a whole different system. That's what I've heard anyway. There's software to evaluate, is your website secure? Have something that pretends to be an attacker. Can it detect vulnerabilities? Even just checking the version that's running is enough to tell you, is it vulnerable? Checking the error logs of your website server, that might be something you regularly need to do, that event auditing. And you can put other software in the way to sort of filter what's getting in and out of your web server. Sort of like a specific web server specific firewall. When you're deploying, say you're writing software to do special applications, you don't run it on the company location. You have a deployment for your developers. They program and test something here, test that it works. When you're testing it, you say, developers, you can't touch the software. We're going to try to break it here. If it breaks, it's not going to affect operations. Once we've tested it, sent back fixes from developers, then we have, you go past the beta test, we have a stable version. Then we actually deploy it out to the production server. And even then, you still tell people there is a new version, you back this up before you update it, and then you don't have any spectacular bugs. You'll probably some bugs found on the production server. And as soon as you find them, you better get them developed, tested, and deployed. When we're attacking websites, something the web server may want to know is not only can I attack and mess up their website, but I can get to the other users? Can I find out what they're doing? So I can attack your browser and fool your browser either to giving up information or letting me do key logging, or let me get information from other people that trust you. Vulnerabilities in various type of programming languages, from Java to ActiveX to other scripting languages. There's lots of possible ways. Here's one type of script that the script does a greeting back to my user. Now, the thing they're emphasizing here is this script, this language, this is running in your browser program. The script, your browser stores the script that is given to it from the web server. And if I am assuming that this is your name, somehow I get it somewhere, your browser can actually be fooled into replacing what this name is, because all this code is on your browser, and the person running the browser can actually edit the script. It's an interesting thing that you can do. So when I'm talking to the server, you could say, hey, I'm gonna tell the server my name is Joe instead of Sam, because Joe has more privileges. If the server doesn't check to see what name you say you are matches how I can verify that you're Joe, I don't let you do anything, because the browser can actually change the JavaScript. And there's other languages like this that have vulnerabilities. The browser can be fooled into going to the wrong place, and you might not even know it, because it does some bad thing and then actually goes to the place you were meant to go to. Fools you into giving up passwords, or it logs your passwords after fooling you to go to that bad website. Good thing to think about here is closing your browser if you've ever been anywhere that you're not sure it's legit code. And of course, don't browse to those places, because they can mess with your browser. Remember, on the client side, not only can I fool your browser into taking you to the wrong website and trying to break into your website, I can fool your computer itself into giving me information from other files on your computer. Even letting me give someone else, having you give someone else full control of your computer. That would be what we call a client side. It attacks the person doing the browsing. So, in order to prevent attacks, completely, patch those browsers. If you see a patch to a browser, good thing to do. If you see a patch to your screensaver, maybe not such a big idea, but a big concern. But patch your browser, and keep a mind of security configuration when you're browsing it. Watch out when it says, "Oh, if you want to allow access to these sites, change these settings." Change the trust settings. Be careful what you're doing when you change trust settings. There's some example of cookies is information your browser is storing, and I can mess with the options under the security options. I can turn on pop-up blockers, and instructions from sites will walk you through this. So get into security, check out the internet options associated with security and privacy. You can go and erase things such as saved passwords. That's one of the horrible things a lot of people do. They save passwords. Do not save passwords if you want to have a secure browser, because you never know, there's going to be a vulnerability in your browser that basically says, hey, send me all the passwords saved to all your accounts if I go to the wrong website, by some vulnerability that I guarantee you is in there somewhere in your browser, fooling it into giving up all those saved passwords. Do not trust your browser to save your passwords. Can't say that enough. So many people do that because it's so convenient to not have to type in that password again. Now we're talking about email, where we need to filter what's coming and going through email. Many viruses have made it through email. I don't hear about them as much. I think partly because people aren't using the clients anymore. Most people are moving to the Google Gmail type things, where that doesn't let you do as much as and has stronger secure code at that server. Where here, my Outlook can be fooled into spamming all my friends in my contacts list. It's going to do it. So filtering for that and watching out for spam, those are the kind of things done with email security. How do we detect content? If we can't read the content of the file, it sets it being encrypted, I can't filter for bad things in the messages. But companies have to watch out for that, because the company can be held liable. They can be sued if they are not catching harassment in the workplace. You can lose intellectual property if you're letting secret information out, letting out that patent information or the trade secrets. How do you prevent that? Well, if it's encrypted, it's a lot harder than if it's unencrypted. You may just say, we don't allow file attachments, regardless of what you think you're sending. If you want to do a file attachment, you have to go to this other server, and we check for what you're sending to it before you're allowed to send it out. Same thing coming in. Now, the client running at the PC is where some protection can be made. But if you're using Gmail, well, that's all happens at the server, and you read your email through a browser. And you have some managed servers. So you basically, I'd say the world is moving to cloud-based email, where the cloud-based email server, you pay them to view the filtering, and you have an administrator that has complete access to all the email on the server. And I think that's a pretty good deterrent to someone stealing information. Unless they're the administrator, they can steal all the information they want. Encrypting the email is a good thing for secrets. Filtering the email, if you have a corporate server or a cloud-based server, you filter it, you check it there. Again, it has to be decrypted there. I have the capability of decrypting it. So if you're encrypting it, your corporation is encrypting it. If someone's doing their own encrypting, then they may fall under suspicion by the corporation. They may say, wait a minute, we want to see what you're sending out. And they may block it until you're able to prove that you're not giving away secrets. Or you may just be on their suspect list. Using Microsoft Outlook, I do not use Microsoft Outlook, but there's lots of settings in there on what to do with things and how to filter things and what warnings come up if I try to send email. Plenty of settings in there. Protecting email, I'm encrypting it. It gets to the server, it's encrypted on the server. They may know where my email is going to, but that actually, I might have encryption through some complicated network, or through a VPN, gets to the other side, and they're able to decrypt it. I'm sharing some sort of secret information with the receiving client. And that's a whole other topic of privacy and certificate authorities and all that. I can choose encryption options. Again, here's Excel, the application for handling the email. I can do that in my Gmail. It's been a long time since I visited my settings in my Gmail account. I've been using Gmail for 15, 20 years now. Now, one of the last topics is phone over the internet, called voice over IP. Basically, audio information is being sent across the network, and one of the security issues there is, can someone eavesdrop on my conversation or kill my conversation by disrupting it? The protocol for turning my audio into digital packets and sending it across is the real-time protocol, because I don't want to have buffering in my conversation. I'm transporting it through one protocol. I'm signaling it about where it can be sent and who it's for. What's the other phone at the other end? That's the signaling part. If there is a flaw in any of these, eavesdropping can happen. Recording of my conversation, breaking into my conversation, disrupting it. The main protocol we hear about in VoiceOver is SIP, Session Initiation Protocol. Older systems have it H.323. So my phone deals with some sort of SIP server. It sends information from my phone through the network, very much like email messages, except the application is decoding it into audio instead of text. Same kind of issues, but different protocols. The RTP is the special protocol for handling voice over IP. RTP and SIP is the protocol and the software dealing with that. If we're dealing with different types of voice over IP, like going from my internet phone to a regular phone, there's translation happening in between. Now, because I want to be able to call anyone that has a phone, it's more of a public type of a network, and people can hack that and track the packets and try to break in. I'm not sure how valuable the information is, but if you're talking about someone sharing secret information, or in politics knowing what their plans are, that can be a major threat to a country or a corporation. Either I can eavesdrop on the conversation or break the conversation, or eavesdrop and pretend to be that person using AI and social engineering to sound exactly like them, asking them for information or to allow me access to some system. So those are your security issues. I can hack a voice over IP system. I can disrupt them or eavesdrop. I can get free calls by fooling them that I paid for it, or fooling them that it's free. And I can start spamming others and then do solicitation, or sell the capability to do that to companies that want to contact me over phone. So basically there's the whole kind of encryption authentication over voice over IP. So SIP identity is a way of authentication. Anything we do dealing with the packets being sent over voice may cause that signal to be buffered and cause breaks in the voice. People are not liking that. They do not like breaks as they're in their conversation. So that's where the real time part of it becomes important. And it has to be prioritized, because we don't want a file download to slow down and break my conversation up. So one of the main things you have to do is prioritize that. Traffic, which may also be a vulnerability. If I know there's a hack I can do, if I can hack voice over IP that gets priority, my hack now has priority. Dealing with other network issues, basically, because I'm using the network and using existing technology, converging, there's going to be concerns about all of that. Got to have good authentication. Other services may have some vulnerabilities. We do not like generally peer-to-peer service. Basically, it's like any desk. They may have all the security in the firewall, but it allows that client in the lab to talk to a peer-to-peer service, the AnyDesk service, saying, hey, let someone in if they log into you with this code. I'm basically giving access through the firewall through a peer-to-peer service like that. So those are scary services, and if a company wants to block it, typically you have to find out what ports are being used, perhaps even a filter they can watch for AnyDesk or LogMeIn traffic or TeamViewer traffic. If I'm using Skype that wants to share files, some antivirus will block that because that's a vulnerability. Instant messaging, I have some sort of server that I send my message to, and basically it's just that my server thinks I'm just talking to a website, and here I am talking to an instant messaging server that basically has a little app that shares communication as though I'm setting up my own little network. Instant messaging, another way to have communication going on, and may have some flaws in that. Directly talking to another machine somewhat bypassing my firewall once I have that connection made. But I may want to have control over that communication. Lots of different protocols, and in each one of these protocols there's a potential for a problem or a bug. Systems on my network through the help communication, SNMP. There's all possible ways of there being a problem in that security between those applications. Getting into a lot of details here in the network, basically think of this as there's lots of ways for applications to talk to other applications, and in every application protocol there is a chance for vulnerabilities, for attack, for a hack. So be up on the latest versions of all that communication. Because applications work with the network, you've got to have network people and application security people working with each other. So that's it there for a quick preview or view through application security, and a lot of other things we've already talked about are involved because it's all connected together in so many complex ways. Hope that was helpful. Any questions, feel free to send them on to your instructor. Have a wonderful day.